Apply the first derivative test to all relative extrema, use the graphing solution. Okay, so we're going to use the first derivative test also. Alright, what do we do now? We take the derivative. The derivative tells me everything. The derivative sign is cosine, so that becomes root 3 cosine. And the derivative of cosine is negative sine. So I get that for my derivative. Alright, and now this is the point where my method kind of starts to break down a little bit. Because there's no real creative, interesting way to factor this or anything, so I just give up and just do it the lame book way. The lame book way, I'm sure there's some weird way.
Factor out a sine.
Yeah, I knew you were going to say, I knew Eel was going to say something. Yeah, you could do that, but it's getting increasingly hacky, right? I mean, as far as like, no? Okay, Eel wants me to factor out a sine.
Don't do it.
I don't think I want to do it.
No,
I just want, don't be ashamed to occasionally just fall back on use a test point. It's okay. What's
Wait,
right?
equal to each other and that works.
Why don't you just
No product rule, it's just the sum of the two.
It's all fancy.
Wait.
I'll just do the, let me just quickly do the,
Just think of one
Why
at
just move it
zero.
over
Root
to
three is just a constant.
Oh.
I'll just quickly do it the lame way, and then maybe we'll do it the cool way. So the lame way would be to first figure out when the derivative is 0. Well, that's going to happen whenever root 3 cosine x equals sine x, and that's going to happen whenever tan x is root 3 by dividing both sides by cosine. Well, we are supposed to be doing this on the interval from 0 to 2 pi. So where on the interval from 0 to 2 pi does tan have value root 3? I just know these things. It's happening at pi over 3 and 4 pi. Bless you. And so, what I might do, I hope, is, go from 0 to 2 pi, and my only critical values are going to be at pi over 3 and 4 pi over 3. So, when is this derivative going to be positive and when negative? I suppose what I can do now is just plug something in. So if I plug something in like, I don't know, how about pi over 4? If I plug in pi over 4, then I'm going to get, these two are going to be the same number, but that one's going to be bigger, so it's going to be positive. You see how I just did that? Yes. And now if we use the Buse's method of common sense says it should just switch everywhere.
Why is it his method?
It's everyone's method. It's your method. It's everyone's method.
It can be the Sydney method.
It can be whatever. It's the method of. It's going to change at every one. Then we get this sign chart. I think this is the right sign chart. You could, if you wanted to be very careful, you could just plug in a test point for each interval. Actually, plugging in pi is not so hard because it's negative root 3, and so that's clearly negative. And now I can plug in like something, whatever works. All right, EO wants to show off and do something cool, like taking the, or maybe not, maybe he just wants to be cool. Maybe it is cool and he just wants to share it with the rest of us. He says factor out sine. That's what you want to do?
No, yeah.
Maybe can I factor out cosine instead? No, I want to factor out sine.
It doesn't really matter.
All right. So if I factor out sine, then I'm left with root 3 cotan minus 1. Congratulations. Everyone knows everything there is to know about root 3 cotan minus 1. Now what?
So it has to be, it's like root 3 over 3. Cotan has to be, root 3 cotan has to be 1.
It's pretty much the same thing. So so this is going to be 0 when sine is 0. So is pi relevant or no?
No, because then cotan is only 5.
It's just a lot more complicated than
Yeah, okay. So maybe we ignore that term for a moment because for some weird reason. And then here we say, okay, so when is cotan root 3 over 3? That happens here and here. And now I just picture the graph of cotan or something?
Just picture the graph.
You can just
No, I picture the graph of root 3.
Speech?
Now I just know the unit circle so well that I know that root 3 cotan minus 1 is going to start positive, then it's going to get negative. Alright, whatever. Okay, good. Can I have this homework? Let's hit pause on this thing for a minute.